Okay, so overriding. Now, as we discussed before, overriding works for dynamic polymorphism, and it's all runtime based. So it basically thinks, okay, so this is going to happen. I know that, but I'm still gonna wait until I'm actually in that situation, and then I'm gonna make a decision, right? So when we're looking at function overriding, the main two things we'll be looking at is virtual functions and the override keyword. This a bit less, mainly our virtual function, right? So virtual function is a function in the base class which essentially says you can expect this function to be overridden or changed in the future by the derived class. So let's say the base function has a virtual function. It sees the keyword virtual. So the compiler says, okay, so you will be changed. You mostly will be changed. So I'm going to keep that in mind. And every time you are called, I'm just going to think and then go to the base function, check everywhere, and then run this function. So it's essentially like a caution, this will change. So don't decide now, decide later at the runtime. So it's dynamic, mind, I know. So this is what it would essentially look like. So your base function would have the virtual keyword and your derived usually will not, but if you are deriving another class from here, then it is good practice to have the virtual keyword here as well. So since the virtual is in the parent, when we have a code like this, so this is our base function, and we're having a function called show, very fun function. So essentially, if I call the show, it should run this, and my output should be base. And I have a derived class, and it is derived from base, and either the show function. Also, one very important thing to notice for overriding, these should be the exact same. Even if one thing is different about it, it becomes overloading, which is the other concept. We shouldn't go there. So very important to differentiate between overloading and writing. So since I have virtual here, when I make my derived, I make a derived object and I'm giving a pointer to that. I'll explain all this comes later. Essentially, I'm pointing to it and I'm asking it to show. Since it is a derived object and since the original show has the word virtual, this base class already knows, okay, so I already knew that this function would change. And since I'm calling this function, I'm going to look for other variations of it. And then it will come here and run this function. So essentially, our output would be derived. So that is how this works. So is this fine, at least so far, just this bit? We'll talk about like errors and things you should avoid later. But just generally how virtual works. Is that fine? Just another thing to like enforce this. Usually, in C++ at least, in modern day C++, it is considered good practice to add the override keyword, which is essentially what this is, this override keyword. It is considered good practice. So just to explain it again, when I'm calling an object from a derived class, it'll look at all its inherited. Let's say I have two functions with the same name. It'll look at the base function first and foremost because it has an order of looking at things, right? And it'll see how this is virtual. It'll say, okay. So the user already said that this will be overridden. This will. So usually in modern coding, at least, you will have something like this here. I will show an example of that too. So it'd be like, okay, so this function has already been marked as like to be overridden, to be changed, and it will look sequentially. It'll look, okay, so there is another one called show, and it matches all my criteria, and it's in the same derived class. So I will run this. That's essentially how virtual works. There is a particular way that virtual works using V table. I will explain that too. But generally, is this concept okay? Does this make sense? Any doubts here? Uh, just like a thumbs up or something. Okay. Yeah. Now errors to look out for, obviously. So you, as I mentioned before, you should make sure that these functions do not differ here because this becomes overloading. It's not overriding, right? And then the return type should be the same. So you remember how I said that just changing the return type does not result in polymorphism. It's not overloading. It's not overloading. And stuff like that. So I know here I said that this is overloading. It's not overriding. So you shouldn't intuitively think, oh, okay, so any polymorphism, any changes I make, it directly becomes overriding. You shouldn't think that way. So even if this doesn't change this into, am I recording? I am recording. Wait, shit. I am not recording. I'm so sorry. One sec. Oh, I am recording. My bad. I'm so sorry. Yeah. So even though this isn't overloading, it doesn't make it overriding either. So just changing the return type does not make it overriding. So again, we're looking at how the compiler looks at this. The compiler would just look at this bit. It does not care about the return type. Then you must not miss the virtual keyboard in the base class. So if I do not write this virtual, or if I don't write the override in like modern C++, it'll directly just call this. It'll just call the first instance it sees, the first function. Okay. So that obviously is not overriding because nothing is overridden. And then access specifiers. So you see how this is public and this is public. It is good practice to make sure that all of these functions are public because you need to access it exterior from the exterior. Now let's say I make something like this private. It becomes messy. Like it doesn't make sense. It's like let's say this is the parent and this is the child, and the child locks their house up essentially, and the parent can't get in. It doesn't make sense. It's very odd, right? It essentially works like that. So you should always be careful with your access specifiers. So it's not necessarily an error. There's nothing wrong with locking your house, but it is not considered good coding practice. So just something to keep in mind. So when using virtual, we have a very particular problem, not necessarily a problem, it's a scenario that happens, and it is called object slicing. So, as you all know, slicing essentially means cutting. You're removing a part of it, right? It's like, yeah, slicing of fruit, types like that. So, it simply means losing the derived part when copying the base object. So, for that, I have very nice diagram. So, let's say this particular cup with this tumbler and this data. Yeah, let's say my cup is my object and the water inside is this data, right? And I am deriving it. So what does derive mean? It basically means inheritance, right? So it inherits all the properties of the regular cup. And on top of that, it adds its own properties and its own data, which is the green part. Now, let's say I am making a copy of this derived thing with the base type. So I'm making a base cup, but all its data should be copied here, essentially. Now, what happens is this cup is too small to hold the extra derived personality, right? The derived water, the derived data, the extra water which makes the derived class unique. It does not have the space to hold all that. So the extra bit is essentially removed. It gets sliced off. So this is what we call object slicing. So if the base class, let's say, it has int A, and the derived class has int B, new. And we know that it has inherited another integer called A from its inheritance. Yes. D1 I'm defining. D1 is an object of derive. I'm defining it to have A as 1 and B is 2. And I'm making B1, which is an object of the base class. And I'm saying that B1 is going to be a copy of D1. So why did you copy this value? Because it has the place to store it. Yes, it has the place to store it. It does not have the place to store B. So that does not get copied. So essentially the object loses its derived personality, its derived behavior, the derived or extra behavior. It is lost. So overriding has failed here, essentially, because intuitively, when you think about it, when you're making a copy of the derived object, you want this because this is what has come extra. So in that way, overriding has been failed. So how do we solve this particular problem? We solve it using pointers. So if you recall here in this example, we use pointers. See? So this is why we use pointers to avoid slicing. Yeah. So the pointer. So essentially, you're creating a pointer which points to the base, and you're making a base pointer. So you're saying make a pointer of this type and make it point to the derived class. And it will use. So essentially, you're making a derived object. You're not making a base object like here. You're not making a base object. You're making a derived object, but you're pointing to its base part. So this derived will have base personality essentially, and its derived personality, its new personality. So you're making a pointer which points just to the base part. So make it point to the object of the derived class, and this pointer sees the derived object and and as a base object. So it sees this. It sees that it's derived, but it chooses to ignore it. So unless you use, so this is if you don't use virtual, by the way. This happens if you don't use virtual. If you use virtual, it works as usual, as I explained here. It's just fine. This isn't a topic we have to know, but it is good to understand. Is there any confusion here? So essentially, my pointer. So instead of just making a copy of base, it's making a copy of this derived cup, but it's just ignoring the existence of this top part for now. It's just conveniently not looking at it in a way, but it still exists. Does that make sense? Any doubts here with object slicing and why we use pointers? No doubts. Now, how do virtual functions actually work? They work with a concept called vtables. I understand that these topics are a bit isolated, but they are like topics we should understand. So, understanding a virtual function or vtables. A compiler essentially creates a table to decide which function to call at runtime. So whenever you use the virtual function, what happens? Yes, I'm sorry.
Yeah, what's the purpose of pointer? Could you please explain it once again?
Yeah, sure.
Thank you.
So here, got messy now. I'm sorry. So you guys understood the problem of this, right? You understood the actual slicing part.
Yeah, that part once again. Yes, few.
Oh yeah, sure. Okay. So let's say I have a base class, right? And again, let's just use this cup analogy, or we'll just use the actual code in itself. So let's say I have a base class and it has a member, a data member of int A, right? And I have a derived class which has an extra data member of int B. Now, according to the concept of inheritance, inside it also has this int A, right? Now I'm making an object D1, which is of the derived class, and it's taking these values. And I'm making an object B1, which is the base class object. And inside, I'm saying, okay. B1 should be a copy of this. I'm very explicitly telling you, I need you to have all this data. Now, B1, it has the space only for one variable, whereas derived has two. So while it can copy this first one, it does not have the space to store the second one. So essentially, whatever information was derived, so you have the base and derived. And in this case, your base would be integer A and derived is integer B. So while you're inheriting your base data, your derived data is lost. It gets cut off, it gets sliced. So this is what we call data slicing. So how do we fix this? How do I ensure that I can still access my base? How can I still make a copy but still have this derived part and still so when I make a copy it should still have this information without virtual when I don't have virtual in play. So this is why we're using pointers. So essentially pointers, even though I mentioned that it's going to be B1, I will make the derived class. And since I split it as my base base as I split it as like the base functions and members and the derived functions and members, I will make a pointer that just points to base. So essentially, I'm not telling it. I'm just saying, okay, so that this is the base. Uh, this is the base. This is I'm sorry. This is the base thing you needed. This is the base you wanted. This is the base you wanted me to copy. Yes, but the derived also exists, but I just don't show it. It's essentially a form of abstraction in a way. So I have just my base properties, but I've still not lost my derived class. So essentially, I'm making an int A and an int B, but I'm just pointing to this int A. I'm not showing it int B. Int B still exists, but I'm not showing it. This is particularly useful when we don't use virtual. Again, this is some since we use virtual now, this isn't an essential topic. Is just to understand why we're using virtual and how it is important and what are the problems we can face when virtual isn't employed and how can we fix it. This is just something to understand that. It was mentioned very briefly in Subin's slides, that's why I wanted to explain. Do you want me to explain it again? Fine.
Yeah, got it. Thank you.
Ah, it works. Okay, moving on. So understanding the virtual function. So very briefly, before we go into the actual explanation, so whenever you see the keyword virtual, what the compiler does is it makes a table and it'll list out all the functions. It'll write the class name, or at least it'll understand it like this. It'll add the class name and all the functions related to it. And each object will have like a secret pointer, which we don't really define. It'll have it within itself. It has like a secret pointer which points to this table. Okay, that's how it generally works. We'll look into the actual definition now. So a compiler essentially creates a table to decide which function to call at runtime. As I mentioned, it will create a function. It will create a table with a list of all the functions. Now, whenever we say virtual, as I said, it's a dynamic polymorphism, so it decides at runtime. So for this compiler to decide this, to make this decision, it needs like a bit of a structure, right? It needs an organized system. That's why it makes a table for ease of access, for it to understand, okay, so I need to make this decision fast. So it will be really helpful if I can have a list. So that is why we have a vtable. So it can compare and execute all these functions easily. Instead of like going through the code line by line, it just very conveniently has all the functions mentioned with its parameters so that you can check the criterion. So when the class has virtual functions, the compiler creates a table for of all the function addresses. So as I said, this table would have the address of each and every function so that we can just quickly access it. So this is essentially how it will store it. So the show function, it'll have a pointer to the base class of show. And if it's a show function in the derive, it'll have a pointer to the derived class and the show in. So this is kind of what it will look like in that table. So every object has a hidden pointer. As I said, it has a hidden pointer. We really can't see it. It's just something like VPTR, so vtable pointer. So it points to this table so that you can easily access each and every address of each and every function address. Okay. So why do we need to understand this? So this understanding is particularly important when we look at this particular diamond problem. So I'll explain that further. Again, I think Nagaraj already took inheritance. So you guys know multiple inheritance. So let's say I have one grandparent and then I have two parents who inherited from the same. So this parent B would have a copy of all the functions and members of A, and this parent C would have a copy of all the functions and members from A. Yes. Now, when the child D gets this and this, it has two copies of everything. It has two copies of everything from A. So when you actually call a function, so this has show. So when I make an object D and I call the show function, it'll be confused. It'll be like, wait, which show do you mean? Like, do you mean this one or this one? Because in all reality, they both are literally the same. So this is where our V table is particularly useful, right? So the V table, it does not, since it's all pointers. So this is essentially what my V table will look like, right? So this is class D. I'm making, so it'll have two copies of everything, but since they are pointers, they will point to the same function anyway. So since it's inherited from A, it'll just point to whatever's in A. It won't point to B and D separately. It'll just point to the base function in A. So even if there are copies of the pointers here, it all points to the same function. So there is no more confusion. This is why it is important to understand how the V table works. So again, if you look at the whatever I've written here, parent B will have one copy of everything from A. Parent C will have one copy from everything of A. And parent D, if we're not using virtual, will have copies of both B and C, which is essentially the same of whatever is in A. So to fix this, we use virtual inheritance, particularly aided by a V table. So since the table has pointers to the various functions, it just points to the base class directly. It doesn't even bother with B and C. It just points to A. So the V table of D will point to either B or C, and that just points to A. So there is no confusion, no duality, no nothing like that. So essentially, if you want a nice example, is two kids and a parent. So let's say, if I don't know if you guys have watched Parent Trap or not. Let's say I have one child and one child. They both would say my parent is this, my parent is this. If you are an external person and you will have all this data about their parents, but you have two copies of the same data essentially. But if you ask a kid to just point, just okay, kid, point to your dad or mom, they point to the same person, right? So you don't have any dual confusion. So that's essentially what is happening here. Any confusion here so far with the diamond problem and V table? Is any confusion? Just, Harshada and Karth.
No doubt.
Okay. Yeah. Now override. As I said before, override keyword is It's not necessarily compulsory, it's just something we do in modern day coding, in modern C++, basically. So beside virtual, we'll just write override. So you see here. So we have virtual, and this is the derived. So if you previously I'd showed an example without this. I just shown something like this, which also works. But using override, especially in modern day programming, is a good practice. So don't forget to use override in like all our exams and stuff like that. So I don't think I need to explain that too much. Now, pure virtual function and abstract class. Now, so you guys see that you see this. This is a virtual function, yes? And this class only has one virtual function. So a function, when a function is declared in the base class but not defined, is what we would call a virtual function. So wait, I'll show an example. So you see here, this is the base class. And I've said that, okay, there will be a function virtual void sum, but I haven't defined it. I haven't given anything here. Not this equal to zero for now, but I haven't defined it. I haven't said, okay, this is how it will behave. I have said nothing like that. And this is the only function in this class. So essentially, a pure virtual function is a function that has a keyword virtual, and it says, okay, so there is a function like this, but I do not know how it will work. So if you see here, the function is declared in the base class, but it's not defined. The essentially the base class says, I do not know how this function works, but it does exist. And all my derived classes will have this function and they have to define it. So it's like saying, I don't know how you'll do it, where you'll do it, how you'll do it, when you'll do it, I don't know. But this should exist and you should all define it. That's essentially what is happening here. So you see how this is defined, but it's not, this is declared, but it's not defined. You don't know how it will work. And dog, since it inherits from animal, it has defined the void sound. It has to have void sound and it has defined how it will work. So that is essentially a pure virtual function. Now, what is an abstract class? An abstract class is simply a class which has only, it has at least one virtual void function. It can have multiple functions, that's all well and good, but it should have at least one of this. Now, why do we particularly call it an abstract class? It simply means we cannot make an object with it. Since this is undefined, when you make an object, it just has this unknown mass. It just doesn't know what do I do with this function. I cannot exist without knowing what this function does. So that is what we call an abstract class. So it's basically a class with at least one pure virtual function, and it cannot be used to make an object because it is incomplete. You do not, since this pure virtual function hasn't been defined, it is incomplete. So it feels that it is, yeah, it's basically, it feels that it's incomplete, so it can't make an object. So it's like, what to say, hand. Like, let's look at a human. Let's say I have a function hand, and like someone is saying, okay, this person, they will have a hand. I don't know how it will look like, what it will look like, when it will come. Nothing. I don't have that information. I just have a hand. So I cannot make an object on me. Like I can't say, okay, this person will exist because I know that there should be a hand, but I don't know how that hand will be implemented. So that's essentially the pure virtual and abstract class. Any doubts here?
Fine, no, no.
Okay. Then finally, we just have UML diagrams. So just like switch to Subinsa's slides for this because it's pretty straightforward. So for inheritance, you will use a hollow triangle head to show it. Again, something that we have already covered. And then for function overloading, you will write the same name of the function, but you will need to specify the difference in parameters for overloading. You will need to like show that. And for overriding, you won't write the word virtual at all, because essentially virtual is a type of abstraction. This fact that we use virtual would be abstracted. But these abstract classes, so while you won't show these virtual functions, abstract classes in particular are mentioned. Just to repeat again, abstract classes are those with at least one pure virtual function, and you cannot make an object of it. So these will be explicitly mentioned that it is abstract. So I'll just switch to Subin sir's slides for now. One sec. Okay. Mm. Yeah. So as I said, inheritance array, hollow triangle, function overloading, you will define the same name, but you will show that the arguments differ, that the parameters differ, whatever. Operator overloading, you would show it is the same operator, multiple operators for different objects. You generally do not show operator overloading in your UML class diagram, but he has mentioned it here. Now, function overriding, you will not show that it is virtual because it comes under abstraction, but you will explicitly mention that you have an abstract class. Now, class name, this is all known. Now, there are three overloads here. So these are overloading, right? But you don't mention that it's overloaded in specific. You just show that the parameters change. So, and then operator overloading. So he has mentioned different operators, and this is for a complex number. Generally, this isn't something we do, especially in really, really big codes. But if he does give us like a very specific question which works with operators and a particular data type, then better to have this written down. So operator, again, like a function name. So just operator plus what it uses and what it's for, what is the output input, and the in-stream and outstream. All of that is given. Then we have function overriding. As I said, overriding that virtual keyword isn't explicitly mentioned, but it just is written twice. So you see draw void double. So you know, as a coder, you would know that this is overridden, but you do not explain that out loud. Yeah, so that's it. Any doubts with UML diagrams? Uh, I think that is okay then. Yeah. So any doubts in general with polymorphism or unit 3 so far? In Because we are done. That's it. Congrats, we have finished polymorphism. But yeah, any doubts in general? Okay. Sorry about the really long session, but yeah, we wanted to finish unit 3 before the next week would be a bit hectic with all our exams coming up. But yeah. Thank you guys for coming. Any doubts, feel free to DM. We will be sharing like the recordings and I will share the notes as well. Yeah.
Will you share it in the group?
Sorry?
Will you share the notes in the group? UVK or
Yeah, I will
Angelin?
be.
Yeah,
No, UVK. I'll send it to UVK.
yeah.
Okay. Done. Okay, guys. Thank you for coming.